Thanks so much. It's great to be here, everyone. Really excited to do this. I've been immersed in the knowledge graph and semantic technology world for about the last 6 years, and I've done this podcast for the last 2.5 or so. And I've come up with the kind of top 10 insights generated with the help of AI. I'll admit, I had to look at my corpus of transcripts over the years. So anyhow, going to try to get through a lot in a very short period of time. So buckle up, put on your seatbelt, and let's get going. First thing I want to talk about is the context that we're in. We're in the middle of the biggest hype storm in the history of technology and business. It's like, I mean, it's definitely impactful stuff, but whether it's like, is it on the order of the first, the introduction of the web? Is it like on the scale of agriculture and industry? We don't know yet. The jury's still out on that. But in terms of the hype machine, I think it's safe to say that it's the most hyped technology in history. So that's an important part of the context, I think. But anyhow, I want to talk about 10 sort of take-home lessons that I've discovered over the years in the podcast and in my interactions with folks. The first is that, at first glance, the AI, the LLMs that have taken over all the oxygen out of the room, and the knowledge graphs, this staid little part of the AI world that I navigate, it seems at first like they're totally at odds with each other, like Alien and Predator, but which is an observation that Fran Alexander made on one of the earlier podcasts in my series. That at first glance, it doesn't seem like there's a lot in common there, but if you think about it from the perspective of how the human brain works and how things can work together, thinking about it, I hope some of you are familiar with Kahneman's thinking fast and slow. The human brain works, has this fast stuff that is automatic and quick, intuitive, associative, kind of error prone. We're all making snap judgments as we navigate the world. But we can make all kinds of really interesting associations and connect dots and gather a lot of information very quickly. That's the fast side. The slow side, the systems two thinking, is more controlled, slow, logical. But you need both. You don't go out in the world with half your brain. Why would you come to your AI architectures with half a brain? That's sort of the argument. But it's sort of like in the same way that, contrasting the fundamental properties that, we bring as holistic humans to any situation. You want to bring the same thing to AI. And that's sort of what generative AI, working together with symbolic AI can do. There's this complementary nature, it turns out, that some people call, in fact, Tony Seal, a neighbor of yours there in London, calls the neurosymbolic loop. And what kind of fleshing out each side of this a little bit, these two systems benefit from each other. I'll talk a little bit on the generative AI side. It comes out of the machine learning school of AI, and it's kind of building on. It's very similar to that systems one thinking. It's educated by broad general knowledge. All the LLMs have read the whole internet. They've got this beautiful conversational interface that's really appealing and engaging. They can look at semantic similarity of words, but we'll talk a little bit about the difference between similarity and actual meaning. They're multimodal. They're notoriously data hungry. So there's that whole side of the generative AI and the learning side of things. Then there's the knowledge. What knowledge graphs fall in the field of knowledge representation, which is in the bigger field of symbolic AI. And you get more domain-specific knowledge there as opposed to the whole internet. There's a lot more information retrieval going on. There's actual semantic meaning as opposed to semantic similarity. You can do real logical reasoning, and you can also capture decisions. I don't know if you've seen the fuss on LinkedIn lately about context graphs and context engineering and decision tracing and all that. Knowledge graphs can help with that. So that leads to the first insight, that knowledge graphs and LLMs complement each other. They offer both. Any system is going to benefit from both that broad general knowledge and the domain specific knowledge. And from a learning paradigm, like Gen AI can learn anything. But at some point, you got to quit learning and just ensconce it as knowledge and not stuff that touch that hot stove every time you walk by it to learn that it's hot. The second point, there's this discovery that a lot of people make when they get into knowledge graphs and ontology, that old saw, if everything looks like a hammer, if everything, all you have is a hammer, everything looks like a nail. So it's tempting to use that tool everywhere, especially if you invested a whole, 6, 8, 10 years of your life getting a PhD, which most people in the semantic technology field have. But your CEO doesn't care about that. They don't care, and this is true of all of us as information architects and content designers and content strategists, whatever. Your boss doesn't care about any of that. You carefully develop practice skills, all the stuff we love to nerd out about. They just want to see that line going up and to the right. That's just how business works. So this is the second lesson. Always focus on a business problem. Ground your work, whatever you're doing in the semantic world, in the knowledge graph world, in clearly understood problem space that addresses a real and measurable business problem. That's how you can keep your job and continue to show the benefits of this stuff. The third point is there's this notion, I don't know how many of you have heard of the semantic web. That's the thing that drives or originated the idea of the knowledge graph. And it was, a lot of people have dismissed it, kind of, snarky engineers and business people are just, yeah, that's one of those failed hippie dreams out there. And well, I beg to differ. I recently interviewed one of the hippies who started that whole thing. This is, I don't know if you've ever seen that famous article now, 25 years old, about the semantic web that was in Scientific American. Jim Hendler, the guy pictured here, was a recent guest on the podcast, and he's one of the co-authors of that paper. And so this is anyhow, the reason that the semantic web is not a failure is, first, semantic web technologies appear in more than half the pages on the internet, on the web. If you've ever done any SEO and seen semantic markup, the JSON LD or RDFA or the other semantic annotations you add to web pages, more than half the web has those annotations. In addition to that, virtually every major technology company, all the FANG companies, Meta, Apple, Amazon, Netflix, Google, and many more, they all use semantic web technology and knowledge graphs in the background, behind the scenes. They never talk about it, but they all have them. And if you follow their job listings, you'll see they hire a lot of knowledge graph engineers. Same thing with traditional industries, fuddy-duddy, old, staid businesses like media and pharma and energy and, businesses like that are all using knowledge graph technology as well. So the semantic web is alive and well. As one of my podcast guests said, Charlie Ivey, he's based in London as well. By the way, London is a hotbed of knowledge graph technology. So if any of you take an interest in it, you're very close to the source of a lot of good knowledge, including Charlie, who lives there. And Charlie said, well, semantic web, is a failure. It's the most catastrophically successful thing which people have called a failure. So the semantic web is alive and well. Fourth point, this guy, Dave McComb, is one of the I don't know, I hate to, stereotype anybody as old, but he's been around a while. He's done a lot in the field, and he's one of the real pioneers of semantic technologies and knowledge graphs. He runs a company called Semantic Arts in Colorado. He has pointed out that enterprise systems, including AI, anything you're doing that involves data, you need diligently stewarded, semantically meaningful, well-organized data and content to do anything. But engineers are always doing this thing where, and I'm sure you've all seen this, they just go out and source data wherever they want it, kind of willy-nilly as they're building each project. This is what Dave talked about, and this results in just messy systems all over the place, and kind of our data just scattered around like a bunch of junk drawers. And it kind of obscure the business meaning. You can miss important connections. We'll talk more about that in just a couple more points. But anyhow, so Dave talks about this first problem, that the fact that data is sourced by application, he calls that the software wasteland. He's got a whole well-developed theory about that. His second book, The Data-Centric Revolution, talks about a solution to that. And part of it, one way to think about that, and this is the fourth point, is that AI needs clean data and meaningful metadata. When Jenny and Jody were talking about, I think they actually used that same phrase, clean data. You want this nice, clean, light, sweet, crude oil, not some messy sludge out of some fracking pit or something when you're going to source your data. So AI needs clean data and meaningful metadata, all of which are related to knowledge graph practice. Fifth point. Ontologists, especially enthusiastic newcomers, and I've succumbed to this myself early in my explorations, you're sometimes tempted to overbuild knowledge graph models. This is what we call in the consulting business boiling the ocean, and you don't want to do that. And one of the ways to think about this in terms of knowledge graphs is that, there's this kind of dream and expectation, I think, on a lot of people's part that a knowledge graph, I didn't talk about this because I don't know, the uneven installed base of information about knowledge graphs is huge. But basically, a knowledge graph is just an ontology, a conceptual description of a domain, and then all the stuff that's in that domain, including language about it. So there's a lot of different ways, short of a full-blown ontology, that you can add semantic value to a knowledge graph and to your enterprise data that's short of a full-blown ontology. Like just agreeing on the terms to use. If you go from a messy, funky, just busy folksonomy to just an agreed upon list of, or just chunk of words that you're going to use, that's going to help a lot. Sometimes you do a more formal list, like a controlled vocabulary of some kind, or constrained pull down list. Whatever it is, you can constrain your list of terms even more. Sometimes not everybody's going to know what those terms mean, so you need to have some kind of a glossary to define the terms you're talking about. Then you get into stuff that a lot of us, many of us, most of us have probably done, organizing taxonomies to organize terms and concepts hierarchically. But then sometimes there's synonyms and other ways to describe those terms. That's where a thesaurus can come in. This, by the way, all these first 5 items I'm showing here, these can all be expressed in an RDF format standard called SCOS, the Simple Knowledge Organization System. And that can drive a knowledge graph just as much as a full-blown ontology, sort of the pinnacle of knowledge graph construction. And that's where the fun stuff is, to be honest. But this leads to the 5th point, is you just always want to know where you are on the semantic spectrum. You don't always need a full-blown, reasoning capable ontology for your graph. Katerina Kari, she's the lead ontologist, or I forget her exact role now, but she's at IKEA. She's back at IKEA. Before that, she was at Zalando. And she's got multiple 7-figure bottom line impacts with knowledge graph stuff that fell short of using a full-blown ontology. So be aware that you can do a lot with just these more prototypical kinds of semantic technology. The 6th point is that we always struggle to agree on what the heck we're even talking about. Fundamental questions like, the blind scholars encountering an elephant for the first time. It's like, oh yeah, clearly it's a big leather wall. No, it's a hose. No, it's a rope. We're just bad at that. And we haven't got too much better over time. And we're also bad at communicating with each other. You think of the game of telephone, where you pass a message around the room, or those old attempts with your brother out in the backyard to try to communicate with strings and tin cans. We're just, notoriously crummy at this. Even the word that we try to use to describe this whole milieu has become a trite little truism. Oh, that's just semantics. And it's like, oh, come on. Yeah, so anyhow, the point here, the 6th point, is that getting people to agree on meaning is hard. Both the communication parts, the conceptual alignment difficulties, and this makes this the biggest bottleneck in knowledge work. It's never technology, but it's rather the need for clear communication, human agreement, human engagement, just good-natured and productive collaborations. One of the best people to talk about this, if you follow only one person after this talk, Juan Cicada at ServiceNow, talks constantly about how this is socio-technical work, not just technical. 7th point, I think we're all familiar with the idea of silos. This business activities, they always tend, for good reasons, we're never going to bust silos, but the data that's captured in them can really hinder enterprise understanding of what's going on across the business. So for example, the classic example in the semantic technology world is like when marketing, sales, accounting, HR, operations, and everybody else, they all use a different word to describe the same concept, like in this case, a customer. Like the sales guy might call him a client, the account rep might call him an account, another department might call him a buyer, the UX people call him a user. There's all these different names for the same concept, and then compounding that tragedy, those different conflations of meaning get ensconced in systems like CRMs and CMSs and accounting systems and all kinds of systems. One of the ways you can deal with that is you put something like an ontology. This is a simple ontology floating above all these enterprise systems, and then you can go and say, oh, this concept we use this word there and that word there, and they look a little bit different, but we can reconcile them because we understand that they're the same concept. Same. You can do that for any number of concepts. This is sometimes called this idea of having an ontology, an ontological understanding of your organization or your domain across the top of this, sometimes called a semantic layer. One of the first people to talk about semantic layers and showing the benefits of connecting things across these silos was Andreas Blumauer. He's at the company GraphWise, which does one of the leading graph databases in this space, as well as some ontology and taxonomy management software. So silos hide connections, knowledge graphs can reveal them. That's point number 7. Number 8, it's tempting to think of knowledge graphs as just another technology. It's another thing, probably another thing many of us are just starting to learn about. But it's the practices that go into ontology design and knowledge engineering. They go way back before any of this technology. I mean, way back. Like the ontology principles that permit us to capture the shared human understanding of stuff in a domain. It comes right out of the metaphysics branch of physiology. Similarly, the logic that underlies and undergirds that permits the really powerful reasoning capabilities that a good knowledge graph can give you, that comes directly from Aristotle and all and Turing and all the people who wrote the RDF standard and everybody since. There's really powerful logic built in as well. And the organization and labeling schemes that facilitate this discovery of knowledge artifacts, they all trace their origin back to library science, just good old-fashioned organizing and metadata things. And the field of symbolic AI, which is kind of an overarching field in which knowledge graphs fit, that traces its roots back to linguistics concepts like the semiotic triangle, which this idea of like symbols reference, thoughts references, how we symbolize things versus what we're actually referring to. It's a whole rich field on its own. And this kind of gets to the 8th point, which is that knowledge graphs are grounded deeply and firmly in the humanities. They're expressed in technical systems. There's some technical stuff we have to do to implement them, but they're built on this foundation of centuries, millennia old human wisdom. Somebody who talks about this a lot, again, I'm going to tell you to just follow everybody I mentioned here because they're all so brilliant. Jessica Talisman was the lead information architect at Adobe for quite some time, and she's now independent. And she talks a lot about the heritage of the information science and information systems, like library stuff in this. And she's a leading practitioner of ontology and ontology design and engineering. So that 8th point, knowledge graphs are firmly grounded in the humanities. 9th point, historically, building ontologies and taxonomies and the stuff that goes into organizing a knowledge graph, it's been really hard. There's a lot to go there. There's a lot of pieces to sort through. But the arrival of LLMs kind of accelerates these once burdensome tasks like entity extraction, the ability, this came up, I forget who mentioned it earlier, the idea of like pulling out of a corpus or a document. I know like the unstructured documents at gds.gov. The LLMs really facilitate and accelerate that kind of stuff, like stuff that would have taken a long time before, much more doable now. Same thing with like taxonomy construction and just extracting terms from corpuses and beginning to organize them. LLMs can get you a good start on that. Now you still need the extracted terms, the draft taxonomies. That stuff still needs a lot of work. But tasks that once took weeks or months can now take just hours or weeks. It's really remarkable how the LLMs have accelerated knowledge graph development. So that's the 9th point, is that LLMs facilitate that knowledge graph building, all those tedious tasks that it can help with. So we kind of add to this understanding of that neurosymbolic loop, the fact that generative AI can help build knowledge graphs. Finally, and this one's near and dear to my heart, and all of our hearts. It's like, even as the Silicon Valley hype machine is just putting up billboards touting a human-free workplace, honestly, I have no idea where they're going with this. Like, apparently we're all going to sit around drawing UBI while they go to their forest retreats. I don't know. Anyhow, but the fact of the matter is, I've done about 300 podcast interviews over the last 10 years. and have had many other conversations, many of you on this call probably, about like what actually is going on in technology work. And this is a slide I've used in many presentations, but basically that like 77%, these are made up numbers, but I think it's pretty accurate. Most of what we do in this work is aligning people around, like that stuff I talked about earlier about the aligning people on language and concepts and stuff. But also about like the culture change and behavior change that has to ensue to make any of this stuff work. Yeah, we can talk about the cool management techniques, the neat agile thing, or the cool new, management system we've adopted. And technology is like this little tiny sliver of a part of it. So humans remain as relevant as ever. And to the extent that we're still serving humans, we haven't quite got to the point of it just computers serving computers. We're going to provide the leadership and the inspiration that these systems need. As another guest put it, Jakob Welch, he's an ontologist who focuses on legal contracts and stuff. He talks about this idea of humans in the loop. He's like, forget humans in the loop. Let's put humans in control. I love that as a way to phrase it. So just a quick review of this. If you want to just snap one screenshot to get all these insights in one place, knowledge graphs and LLMs are naturally complementary. They help each other out a lot. Always stay focused on a business problem. That's how you keep your job in this day and age. The semantic web is alive and well. It's not a failed hippie experiment. It's quite popular out there. You just have to look for it. AI needs clean data and meaningful metadata. And knowledge graphs, just by their dint of their very existence, knowledge graphs encourage that. Kind of always be aware of where you are on the semantic spectrum. Be aware that there's power and utility across that spectrum, that you don't have to be a full-blown fancy pants ontologist to get the benefits of this. I don't have to tell you this. Everybody knows how hard it is to get people to agree on meaning and then articulate it. Silos hide connections, knowledge graphs reveal them, that notion of the semantic layer. Keep that in mind. And knowledge graphs, and never forget this, the knowledge graphs are grounded in the humanities. That this is, phrased as a technology thing, but it's really a human activity. And LLMs, it's really great that they can facilitate, kind of ease a lot of this human burden that we face, and put humans in control, not just in the loop. And I added one more slide during Rafaela's presentation. One of the things that occurred to me as she was talking is that this notion of so much of what we're talking about is content and things you might do with content, and the semantic modeling and the semantic stuff that I've been talking about. A friend of mine, Mark Salvatierri, he's a content, I don't even know his title, but he works at ICANN, the domain name registrar authority. He and I met. He's the only person I've ever seen at both knowledge graph and content strategy events. So he and I are kind of this weird little unit, small cadre of people who span those two worlds. And there's a real problem in trying to model content with RDF. I just saw a love from Rafaela. She'll get this, but trying to connect the dots on this. I just want to, it's kind of a caution, just don't get too excited about it. I'm building a system right now that I'll actually announce in Utrecht in a couple of weeks, that relies on good old-fashioned CMS technology, but then expresses it in a knowledge graph. So anyhow, thanks for listening to me. I'm Larry Swanson everywhere, mostly LinkedIn, mostly my website. And I hope I did that quickly enough that we have time for questions.
That's just the really great timing, Larry. Thanks for that. Fascinating. We've got two written questions. Do you need terms before lists, before taxonomy, before ontology?
Some people would argue that, like Jessica Talisman, that woman that I mentioned, she talks about the ontology pipeline and talks about that it is sort of you can think of that as both a continuum. But there'll be situations, for example, like pharmaceutical research. Like if you're in a situation where you have to develop a way to associate treatments, conditions, interventions, patient profiles, that kind of thing, you can't really do that with just taxonomy. So there are occasions when you need to start. I guess the thing to be aware of there is the capabilities that are enabled with each level of semantic practice, and just do what's appropriate in the situation.
Okay, this next question is quite a complicated one. Somebody asks, How can we start getting agreement on meaning and controlling terms? In government, we're starting to map domains and can use LLMs to extract entities. But how to make the case? Showing the answers people are getting from AI feels like more of a business case is needed, but how?
Yeah, that's interesting. I could pull up some slides. I'm doing a presentation tomorrow at a big Fortune 100 company to their semantic team about one of the things I talk in there is about this semantic tightrope that we're walking right now, because AI LLMs are amazing. They're so powerful. I use them every day. I use them to prepare this talk. I'm using them for my job hunt right now. There's all kinds of things that they're amazing at. But there's a paper I'd recommend to everybody. It's published about 2 or 3 months ago called The Epistemological Fault Lines Between Human and Artificial Intelligence. And that paper gets at like the reason we're walking this tightrope, and Michael Ian Tosca, who some of the folks on this call might know, has talked about this as well, in the context of, like, he calls it the precision paradox, that there's this that epistemological fault lines paper, they coined a term called epistemia, this notion of like this fluent language that's very persuasive and polished and solid sounding, but it's not always based in logic. It's not always based in fact. And so especially if you're in any kind of like high stakes terrain, finance, pharma, government, I'm going to guess, those are areas where you want to be aware that it's so subtle too, because the LLMs are getting so good and so plausible, and you just have to be the reason I use a guy on a tightrope to illustrate this point is that you just have to be really cautious and aware that you're not going to know, the LLMs won't know that they're saying something that's not factual, and because they're so plausible and have set you up with all of their previous good answers that you don't know. So that's the precision paradox that Michael Ian Tosca talks about. So it's like we need to sort this out clearly, but I don't know exactly how to reconcile these dynamics, and a lot of which involves just being a hypercritical consumer, being a fan, but being a hypercritical consumer of the technology as well.
Yeah. Has anybody got any questions they want to shout out before I basically wrap up? Okay. Larry, I noticed you said something. I just couldn't help but quoting it back to you. Quotes, ontology is the cool stuff. Yeah, I'm definitely going to carry that with me.